So let's take a look at number 1. We want to find the slope, distance, and midpoint and leave your answer in simplest radical form. So you guys have to know the slope, distance, and midpoint formula for your quiz tomorrow. So our slope formula is y2 minus y1 over x2 minus x1. So let's find the slope first. I'm going to start by labeling my points. I have x1, y1, x2, y2, and then I just plug everything in. So that would be 6 minus 0 over negative 3 minus 1. So 6 over negative 4. Can I simplify this? Yes. What does it simplify to? Negative 3 over 2. If you can simplify it, make sure you simplify it on the quiz tomorrow. All right, next let's find the distance between these 2 points. What's my distance formula? So x2 minus x1 squared plus y2 minus y1 squared, all under the square root. So again, let's just plug everything in. So x2 is negative 3 minus x1 is 1 squared plus y2 is 6 minus 0 squared. Negative 3 minus 1 would be negative 4 squared plus 6 squared. Negative 4 squared is 16, and 6 squared is 36. So we add these together, and we get 52. Always check and see if you can break down your radical. So the square root of 52. What are 2 factors of 52? 2 and 26. 2 and 26. And 26 breaks down into 2 and 13. If you said 4 and 13 from the start, that works too. You'll get the same factors. Do I have any pairs of numbers here? 2. The 2's are a pair, so what's going to come outside of my radical? 2. And what stays on the inside? 13. Awesome. So if you have a pair of factors, circle it, that comes to the outside. Anything that doesn't have a pair stays on the inside. All right, and lastly, let's find the midpoint. So our midpoint formula is the sum of the x's divided by 2, so x1 plus x2 divided by 2, and the sum of the y's divided by 2. So x1 is 1, x2 is negative 3, y1 is 0 plus 6 divided by 2. So 1 plus negative 3 would be negative 2 divided by 2, and 6 divided by 2. So this simplifies to negative 1, 3. So this would be our midpoint. Right here. Let's look at 2a. So we have to find the slope, y-intercept, and graph it. So given my formula here, how do I find the slope? Perfect. I'm going to put it into y equals mx plus b form. Whatever is being multiplied to our x, that is our slope. So I'm going to move the 9 and the x over, so add x to both sides, and subtract 9 on both sides. So 3y is equal to x plus 9, minus 9. What can I do next? Divide everything by 3. So y is equal to 1/3 x minus 3. So what's my slope here? 1/3. And what's my y-intercept? Negative 3. So on my graph, where would I start? -3 on the y-axis would be my first point. And then what's my next point? How did you know that? The slope. So the slope tells me my rise over run. So I'm going to go up 1 and to the right 3. -3 works. All right. Let's look at number 3. So determine if the lines are parallel, perpendicular, or neither. So what do I need to find to determine if the lines are parallel, perpendicular, or neither? The slope. So I'm looking for the slopes of each of these. And what would it mean to be parallel? Same slope. What about perpendicular? Opposite reciprocals. And then neither, they would just be totally different numbers. So let's look at B. How would I find the slope given 2 points? So from line 1, how would I find the slope? Perfect. We use our slope formula. So I have x1, y1, x2, y2, and my slope formula is y2 minus y1 over x2 minus x1. Just plug it in. So this would be -7 minus -16 over 0 minus 1. So if you subtract a negative, it turns into a plus. So -7 plus 16 would be 9 over -1. And what's 9 over -1? -9. And we can do the same thing for line 2. So I have x1, y1, x2, y2, and plug everything in. So 11 minus -7 over -1 minus 1. So when you subtract a negative, it turns into plus. So 11 plus 7 would be 18. 1 minus 1 is what? -2. And I can simplify 18 divided by -2 would be -9. So what do I know about my slopes here? They're parallel because they are the same. Correct. So looking at A, again, I only care about my slope for these types of questions. So how would I find my slope for the first equation here? Subtract 5x, perfect. I want to put it into y equals mx plus b form, but again, I only care about my slope. So the y-intercept doesn't matter. So this would be y is equal to -5x plus 9. What's my slope here? My slope is -5. And then for the second one, I'm going to do the same. I can add 1 to both sides. So y is equal to -1/5 x plus 1. What's my slope here? -1/5. Are these the same? Are they opposite reciprocals? No. Be careful. They're not opposite because they're both negative. They're not opposite reciprocals. So what type of lines do I have here? Neither. They are neither parallel nor perpendicular. I'm going to do B for number 4. So write the equation of a line in slope-intercept form that is parallel to this line and goes through this point. So slope-intercept form, I'm going to need my slope and my intercept. If it's parallel to this line, what does that tell me that my slope is? The same. It's going to be the same as my slope from this line. How do I find my slope here? put it into y equals mx plus b form. So I'm going to subtract the 6x over. So 2y is equal to negative 6x plus 4. What can I do next? Divide everything by 2. So y is equal to negative 3x plus 2. So what's my slope here? Negative 3. Because it says parallel, it's the same slope. What if this said perpendicular to the line? It would be 1/3. You would take the opposite reciprocal. But here it's parallel, so we're using the same slope. What can I do next? I can plug the points into slope-intercept form. So I have y equals mx plus b for slope-intercept form, which is what it's asking. So I have my slope, which is negative 3. What else do I know? What else do I know? The x and y. X can be 4 and y can be 2. So 2 and 4. Do I know what my intercept is, my y-intercept? No, but I can solve for it here. I have everything else. I can solve for b. So 2 is equal to negative 12 plus b. What should I do next to solve for b? Add the 12 to the other side. So 14 is equal to b. So now that I know my slope and my intercept, how can I write my answer? Perfect. Y equals negative 3x plus 14. The only two things that go into your equation are the slope and the intercept. Make sure you have x and y, just as x and y. All right, for 5, we want to state the domain, range, and intervals of increase, decreasing, and constant. So looking at A, let's find our domain and range first. So domain is x or y values? The x values. So I'm looking from left to right because it's always smallest to largest for domain and range. Yes. So looking at our smallest x values over here, it would be negative infinity. Perfect. Now our graph, going from left to right, it stops here. We have a hole. We have a hole at what x value? A hole at 1. Do you think I put a parentheses or bracket here? A parentheses, because it's a hole. 1 is not included. Right here, we have no graph. There's a hole at both of those points. But then our graph picks up again, so I'll do a little union sign to include the next part. Where does our graph start again? At 1. But again, I put a parentheses because it's not including 1. And where does our graph end? 4. 4 with a bracket. Awesome, because we have a closed circle there. Yes. So for the domain, you're only looking at the x values. If it helps you, cross out all the y values and just look at the x values. If it helps you, put negative infinity here, positive infinity here. So because our graph goes forever in the left direction, that's why it's negative infinity. All right, so let's look at our range now. So range, we're looking at what values? We're looking at the y values. So if you wanted to, you can cross out all the x values and put a negative infinity down here and a positive infinity up at the top. So again, we start from smallest to largest. It's the same as the domain. So we start down low and go up high. Where does my graph start? Negative 1. Is that a bracket or parentheses? A bracket because there's no open circle there. So it's including negative 1. That's where our graph starts. Now we keep going up, up, up. Where does our graph stop? Infinity. Perfect. Our graph doesn't stop. This arrow keeps going forever. Even though this right side stops, if I put a line here, my graph still goes up. It still touches up here. So my graph goes to infinity. Does the infinity get a bracket or parentheses? A parentheses. All right, let's do our intervals of increasing, decreasing, and constant. So where's my graph increasing? From 1 to 4, perfect. So from here to here, we're increasing. For increasing, decreasing, and constant, remember we always put parentheses, and we only look at the x values. So from 1 to 4, I'm increasing. Am I increasing anywhere else? Where? 0 to 1. We're looking at the x values. So from 0 to 1. Am I increasing anywhere else? No. So let's go to decreasing. Where am I decreasing? Perfect. Negative infinity to 0. Awesome. So because this goes forever in the left direction, we're forever assuming that it's just decreasing, decreasing until we get to 0. Am I constant anywhere? Nope. So if on the quiz it says increasing, decreasing, constant, like this, and had blanks to fill in, what would you put for constant if you're not constant anywhere? None or NA, or you could leave it blank. Just don't put 0. You can put none or NA, or just don't put anything. But just don't put 0, because 0 is a number. Yes, Bianca?
Does it matter what order the increased one is for like the number?
You always start with the smallest to largest, so I would probably do it the other way. But I don't think it matters. Yes. Because we're increasing from here to here, so from 1 to 4.
And then do we have brackets for increasing and decreasing?
Only parentheses. So increasing, decreasing, and constant is always parentheses. Any other questions here? All right, let's look at B. So let's start with our domain. So domain, we go from left to right. We're looking at our x values. So what would my domain be here? So it starts with negative infinity because this arrow points forever in the left direction. Where would it stop? Do I have a point that's included at 2? Even though there's a hole there, what about this one? Yeah, I have a point that's included at 2, so I don't have a gap in my graph here. Even though it looks like it, I don't have a gap in my domain because 2 is included. So it would be infinity. All right, let's do our range. So starting down low at our smallest y values, where does our graph start? -1. Bracket or parentheses? Bracket, because it's included. What do you think comes next? But what about this piece here? I don't have anything in my graph from -1 to 0. So what do you think I should put next? We just closed it. It's just -1 there. We just have a point at -1, so we have to include that. Where does our graph start back up again? 0. Parentheses or bracket? Bracket, because we don't have an open circle at 0. It's closed. So we put a bracket, 0. And then where does our graph stop? Infinity. Parentheses. It's always a parentheses when you have infinity. An open circle here. 1 is still being included because, like, at the x value 3, y would be 1. So it's still included. It looks really weird when it's a constant, but even if this was an open circle, because this is, like, technically included because we have a line there, it would still be brackets. So that's for the range. All right, let's look at increasing. Where am I increasing? 0 to what? 2, perfect. For increasing, decreasing, and constant, we're just looking at the x values. So I'm increasing from 0 to 2. Where am I decreasing? Where? Negative infinity, awesome, to 0. And then where am I constant? 2 to infinity. All right, I'm going to do B for the piecewise. So starting with our first piece, what numbers would I plug in? -2 and -5. If I plug in -2 for my x, what's my y going to be? 0. And at -2, 0, do I have an open or closed circle? An open circle because it's just less than. So I have an open circle there. So I'm going to go to the left to -2, stay on 0, put an open circle. Same thing with -5. When I plug in -5, what's my y? 0. Do I have an open or closed circle? Closed circle. So I'm going to go to the left to -5, put a closed circle. What do I do next? Does my line have any arrows? No, because my graph here is just from -5 to -2. So for my first piece, it's only from -5 to -2. It's just that little piece. It stops and it ends at these two numbers. Yes.
So it's always, the x is always going to be the numbers in that, like.
So you're always going to plug in for x the numbers that it gives you. But if it just gives you one number like here, you would plug in an additional number too. But something that satisfies this. So if like 2 is less than x, I would have to plug in like 3 also. All right, let's do the second piece. So what number should I plug in here? 1 and -2. I'm going to plug in -2 first. So I have -2 squared plus 4. What is -2 squared? 4, but I also have that negative on the outside, so it's -4 plus 4, which would be 0. So I plugged in -2 and got 0. At this point, do I have an open or closed circle? A closed circle because it's less than or equal to. That equal to means that it's a closed circle. So I'm going to go to my graph. At -2, 0, put a closed circle. Next, we want to plug in 1. So I have -1 squared plus 4, which would be -1 plus 4, which is 3. So I plugged in 1 and got 3. Do I have an open or closed circle? Closed circle. So on my graph, I go to the right 1 and up 3. Put a closed circle there. Do I put a line between these 2 points? No, because what type of graph do I have here when it's an x squared graph? It's a parabola. So there's some type of curve that's happening in here. So in order to figure out what my graph looks like a little bit better, what else can I do? Plug in another number. Plug in some number between -2 and 1. So what would a number be? 0. Perfect. 0 is an awesome number to plug in. So I have -0 squared plus 4, which is just going to be 4. So my next point is 0, 4. So I'm going to go to my graph, stay at 0, go up 4, and I can connect these dots with a curve like that. If you also wanted to plug in -1, 2, that's totally fine. You can plug in as many points in between those as you want. It's just showing you the shape. And let's look at our third piece. What's a number I'm going to plug into my third piece first? 2. So I have -2 plus 3, which would be 1. So I plugged in 2 and got 1. Do I have an open or closed circle here? An open circle, so I'm going to go to the right 2 and up 1. Put an open circle there. What's another number I can plug in? So somebody said 1. Is 2 less than 1? No. So that doesn't satisfy it. So I have to plug in something that's bigger than 2. 3. So -3 plus 3 would be 0. So I plugged in 3 and got 0. Remember, the second point here just shows me my direction. So I'm going to go to the right 3 and stay at 0. How do I connect these 2 points? Draw a line. Where do I start my line? At the open circle, and it goes through the second circle. If you also wanted to plug in 4, 5, 6, you can plug in as many points as you want. It's fine. But you start at the open circle and go through the other one. If you put an arrow going this way, that would be wrong. You start at the open circle and go in the direction of your second point. Yes.
So when you got x
Is less than or equal to or greater than or equal to, it's a closed circle. If it's just less than or greater than, it's an open circle. So that equal to means that it's included, so it's a closed circle. With these graphs, they're going to be functions still. It's a piecewise function. So if your graph looks like this, let's say we had a point here and a line going that way, and another point here and a line going that way, is this a function? Think about your vertical line test. If I put a vertical line here, I touch at 2 points. So this is not a function. So your graph will not look like this, okay? If you have 2 lines that are crossing each other, you probably did something wrong. So your piecewise function is still going to be a function. You're not going to have lines that intersect like that, because this would not be a function. Any other questions for your quiz? So what she's saying is if we had like 1/8 from when x is 1 to, let's say, 2, like that. From 1 to 2, we would be at 1/8, so it'd be like here. Like just barely above 0. For the second piece, if I plug in -4 and 0, so starting with -4, what's the absolute value of -4? 4, but then I have a negative on the outside, so it would be -4. So I plugged in -4 and got -4. Do I have an open or closed circle at this point? Closed circle. So that would be down here in a closed circle. Next, we want to plug in 0, so I have the negative absolute value of 0, which is just 0. So I plugged in 0 and got 0. Do I have an open or closed circle here? Closed. So because I have a starting and stopping point, I just connect the 2 points. There's no arrow here. For the second piece, what do we want to plug in first? 0. So I have 4 minus 0 squared, which would just be 4. So I plugged in 0 and got 4. Do I have an open or closed circle here? Open. So at 0, 4, I have an open circle. What can I plug in next? I can plug in 1. So 4 minus 1 squared, which would be 3. So my point here would be 1, 3. Because this doesn't have another ending, it's going to go forever. So I'm going to have an arrow. So this one just tells me the direction. So I go the right one, up 3. It's not a line because we have that x squared. So I'm going to plug in another point just to see the shape of my graph. So let's plug in, I can plug in 3. So 4 minus 3. Actually, I'll plug in 2. It doesn't matter. But 4 minus 2 squared would be 4 minus 4, which is 0. So I plugged in 2 and got 0. So there's my other point. So I know my graph is going to have this shape. Again, if you wanted to plug in 3, you would get like -5, which would be here. So it kind of just tells you the shape even better.